Hello all. Today we are solving LeetCode problem number 401, a binary watch. So you are given a binary watch which has 4 LEDs on the top, which represents the hours, which is from 0 to 11, and 6 LEDs on the bottom, which represents the minutes, which is from 0 to 59. So each LED represents a 0 or 1, which is a binary value with the least significant bit on the right. So for example, they are given 4:51, so you can neglect this PM which is mentioned in the watch. So you have this hour and a minute here, so which is 4:51. So due to which this this bit, that is the 4 the third one, right? So this 4 is turned on, and for 51 we need to turn on this 32, 16, 2 and 1, which is nothing but 32 plus 16 plus 2 plus 1, which is 51. So this is how you turn on the bit so that you get this time as the output. So we are given an integer called turned on, which represents the number of LEDs that are currently on. So written all possible times the watch could represent when as per the turned on, right? So what we have to return is they have explained about the hours and the minutes, how we are calculating the hours and minutes from this digital watch, right? The binary watch, and we are given a turn down. So based on turn down, we have to return all the possible times the watch could represent, all the possible times. So for example, we are given turn down as 1. So before getting into that, let me read out these constraint. So we have this as 0 1 0 0 is not valid. This should be 1 0 0. So in hours it should not be represented as 0 1 or 0 2. It should be represented just 1. And in terms of minutes, it should not be 10 and 2. It should be represented as 10 and 0 2. This cases should be handled properly because we are returning the string value, so we can handle that at the end. So before that, we are given this turned on as 1. So let me write down the bits. So hour is equal to, you start with 1 2 4 and 8, which is nothing but 2 power 0, 2 power 1, 2 power 2 and 2 power 3. So using which you can represent the hours from 0 to 11, right? And you have minutes, that is this starts from again 1 2 4 8 16 and 32. So this can represent the minutes starting from 0 to 59. So this is nothing but 2 power 0, 2 power 1, 2 power 2, 2 power 3, 2 power 4 and 2 power 5. So we are given turned on equal to 1. So which means this, if this bit is turned on, then we have to return all the possible turned on, right? So first thing first, if only this particular is turned on, then we will have the minutes added as 0 0 1 into the list, right? And then if only this is turned on and only this is turned on and this is turned on and this is turned on and this respectively, you will get 0 point 0 0 2 and 0 0 3 and 0 0 4 and 0 0 8. Then next comes 0 1 6 and 0 3 2. So this is all about the minutes. And in terms of hours, you again have 1 2 3 and 1 2 4 and 8. I'm sorry about that. So 1 0 0 and 2 0 0 and 4 0 0 and 8 0 0. So you may wonder, why can't we represent 3? So 3 is nothing but uh, the binary representation of 3 is 1 1, so which means 2 bits, so 2 turned on, so which does not equal to the given turned on, right? So due to that reason we will not consider 3, so we have to return all these as a single output in the form of list, and this should be the form of string. So that is what exactly we are doing. So how are we doing? First we will iterate the hours, so which will be from 0 to 12, sorry, 0 to 11, which is of length 12, and minutes 0 to 59, which will be of length 59. Sorry, this should be 60s. So sorry about that. So you iterate these many times, you will get all the possible combination and compare with the turned on, and then you find the values whichever is matching and you append it to the result and then return it. So with this idea, let us go ahead and code this up. So we start with creating the result. So result is equal to empty list first, and we start the for loop for h in range. This should be 12 times because of the har is 12, and for minutes it's 60. So for m in range 60. So now we are putting down the condition if the h dot bit count. So we are, this is a function, in fact, bit count. This will give us a number of turned on bits. So we will add this with the m dot bit dot count, so which will give the total number of turned on bit, and we will compare with the turned on. If it is equal, then we append the value into the result, right? So this should be m dot bit count, and which is equal to turned or on. So if this is equal, right, then what you do is first you have to also check this piece of condition there, right? So because of that, you will create m will be equal to string of m, and now we put a condition that um, if no m will be equal to m if the length of m is greater than 1. Okay, if it is greater than 1, which means you have to the 0 or something is there, so it is, or it is above 10, so then you do not need to do any changes. If it is not there, just a 2 or 3, any single digit is only there, you have to add a 0 in front of it. So else you add 0 plus m, right? And now result dot append, you will append the string of h added with a colon, and that is added with m. So this is how you append the value, in fact, in the string format, and then now you can return result, and let us run it. Okay, bit count, this should be I, there's a typo. Yeah, let us submit it, and there you go. Thank you.